Hello, and thank you for watching B-Sides. My name is Sebastian Kramp. Today I want to show you something about ITSIs and things I've seen in the field. Many companies have already implemented ITSI and use it for a single pane of glass, but it could become a resource-hungry monster, hard to handle and give misinformation if you don't know how to set it up correctly. I'll talk about some do's and don'ts and also explain what happens if you disregard them. After this step, the basic concept is clear and we'll discover how existing systems can provide valuable data. Out of this data, you can construct service dependencies automatically or keep them up to date. As an example, we'll take data from a service bus, VMware, and a production line. The first sentence you always have to think about is don't think too much in techniques. Often ITSI is in the hand of admins, and admins love their product, they love their systems, they love how to work with all the fancy stuff they have. But there's a problem. ITSI isn't built for showing devices as a service. For example, firewall itself is not a service. The firewall is a device which can do something. So don't do this and display devices as a single service. In this case, our service should have the name Internet Access Service, for example. And those Internet Access can be measured by relation between blocked and allowed traffic, sources which are outgoing, or destinations maybe by device. So you have some advantages by building those services more in an organizational way or have the service which is doing a specific work. So what would be if we have got a backup firewall, for example, or a backup device by a mobile system to still have internet access while the main cable is destroyed, for example. So in this case, you could check, is my connection to the internet available? If it's fast and if my main firewall reports information, the system of internet access is healthy. If my backup system is working, often the speed isn't that high and the availability of my main firewall isn't there anymore. So the internet access service is still available, but not that good. And if it's not that good, the performance can be low, for example, and also the service level will be low. Another problem is many admins try to build a wire map. So if you have all your devices which are plugged behind each other, they try to display this in ITSI. But this isn't the way how ITSI works, because ITSI is, as mentioned, for processes. Here is an example. Someone had put his mail server behind a firewall. Don't do this. In this scenario, it says if your firewall won't work correctly, or if your firewall fails, your mail server is destroyed. And that isn't true. So the better way in this situation would be to have a communication service right behind those internet access service. Then the information would be correct, because if your internet connection service fails and you don't have a backup system, your communication service is not that available as you suppose. As mentioned, many admins try to display all the dependencies in one big dependency tree because the base information, everything depends to each other, is correct, but this is not the way how ITSI works. ITSI is, as mentioned many times before, for services. And if you do a wire map, you have the top service, my company, and your company isn't fully out of order if some base technologies will fail. And on the other hand, if you try to display all technical dependencies in one tree, you can't see anything anymore. Here is an example. As you see, the map is that big and there are so many dependencies from one to another service, no one can see which other service is impacted, for example. Don't do this. You have to stay in a simple organizational view, and the view must come from the top to the bottom. That means I have to check my top service and have to go down which is needed to have my top service running. Your top service, for example, can be the communication service, where underneath there is email service, telecommunication service by phone, or also some other groupware systems. But this is just enough for a communication service. I'm sure you know by which KPIs a phone service or an email service or a groupware service can be measured, and what will happen if one or many checks will fail. If you have everything in one tree like you have seen before, you can't figure out the root cause visually. Also, you aren't able to build episodes out of notable events. Because if there are notable events out of one service, you can't see where this service belongs to and which other service is impacted, so that a top service isn't working anymore, or maybe there is a part which needs assistance to work properly. More about notable events and episodes later. By building everything in one big dependency tree or in a wire map, you can't set permissions, because even in ITSI you can set permissions who is allowed to see which dependency tree. If you don't do it the way you should do, if you haven't understood the concept of ITSI, your whole project will fail. Try to understand the way how the system works in technical ways, in conceptual ways, because otherwise you will get a headache. Everyone will ask you, why have we bought this project if it can't display the information that we need? It looks like everything is done, but to be realistic, if you have implemented it like the way it was shown, it is totally useless. As I said, it was really simple, wasn't it? But it's just good to know. While we've done now the conceptual stuff, we'll have a look into the technical stuff, because there are also many things you have to think about. Here are just a few. I'll just show you. After we talked about the concept itself, we'll have a deeper look into techniques. Also in techniques, we have to understand how the system works, how the application works. So there are some rules you have to think about. The first thing is, don't write too complex searches which take too much time to get the results, because all your searches are recurring. And when you have long-running searches which are recurring in small time windows again, it could happen that you have so much load on your CPUs that you can't do anything else. And your CPU cores aren't limitless. So here's a small example. In this example, we have a machine with 4 CPUs. And we have a search which takes 5 minutes to run, and will run each minute. So as you see, the first, the second, the third, and the fourth search is running. And when the 5th search wants to start, there is no CPU core available to start this search, because the first and the second and the third and the fourth are still running. So the search is skipped. Next minute, the 5th search wants to start, but the 6th search also is starting, and just one of them will get the slot to run. And then, if this happens, you have many skipped searches in your ITSI or in your Splunk. So performance and writing searches which are low weighted is key. To need less performance, ITSI works with KPI-based searches. Those KPI-based searches are similar to searches in dashboards, where you have one search, and out of this base search you can get many information which are needed in further steps. So now I try to explain a bit more what happens if you don't use base searches. In this example, this green bubble, this is just one service. And the service needs 3 KPIs. And as you see, for each KPI, there is an own search. That means 3 searches have to run, for example, each minute. Well, you better don't do this, because you have 3 searches which will run each minute. You have the possibility to build one big search which gives you all the 3 information you need out of one search run. So that means you will have exactly the same information but with a lower performance. And as you see, it is divided by 3, the performance which is needed in this case. Another example why we should do this in this scenario is if we have a KPI-based search, we have the possibility to build service templates. And in a service template, it is like a template as mentioned. You can say, well, I need those 3 KPIs, which comes out of this base search. And why it is a template? This template can be used several times with exact the same searches in. And if you use this template more than once on several different services where we have different entities, when you have created this template, you can link this template to many different services. Like here in this example, we have mapped one template to 2 services. That also means we have less performance needed, because now it's just one search with 3 KPI for 2 services. So as you see, building those KPI-based searches and those service templates is really, really easy. It just takes a few seconds more and you have a much better outcome. So you can save so much performance by doing this. And the next advantage is it's easy to update. So if you, for example, want to have more KPIs in your service template, you can create an additional KPI-based search, add those values you want to get out, put the values as new KPIs into the service template, and then you can push those information to the service template. But in this step, you have to be careful. If you override the entity rules, all the information which are set up as entities in your service template will override all the information in all services where the service template is linked to. So in this example, it's enough to override the KPI thresholds and alerting rules. Pushing the changes now would take effect directly. So you have seen our entities will be defined in the service itself. So if we build our service template, we don't know which entity will be selected in each service. Of course, the professionals of you would say, well, we could take entities which have a specific flag, but in this case, we keep it simple and say we want to add our needed entity in our service manually. So during service template creation phase, you can say as entity title, we just want to match a value which must be defined in the service. So by linking the service template to the service, you have to edit the entities directly in your service. In this case, just typing in the name. Other things you have to keep in mind. If you write searches which just collect data, don't end with some aggregations, because ITSI doesn't like it. If you have a KPI-based search, for example, or a normal KPI search, you have aggregations which are done by ITSI itself. This is because you have to say, well, I just want to have my entities and the information for each entity, and then I just want to have an aggregation for this KPI and so on. That means if you do the aggregation before, ITSI doesn't know what to do. So you better have really simple searches and do all the aggregation stuff in the wizard. If you don't do it this way, your workload will be extremely high and everyone is wondering, why does my ITSI take so much performance? There are also some tricks in operating. Operating a small thing like, well, let's do it up, but it must be done by someone else. But if you build it up really in a good way, it might be much easier for everyone who's working with this. And also it gives you a better value, a better outcome, because all the episode building and so on, it's a thing which must be in the concept first. And if you have those trees with in a great structure, then you have good information out of ITSI where the value is really high and all the people can work with it, and also the C-level are really thankful for it. So now the basic stuff is done. We have the correct service dependency trees, we have our searches with low performance and can work with the system. Now we want to have the value out of our service dependency trees. So what is a dependency tree? The dependency tree is a business service or a technical service, which we are monitoring. We're doing all the monitoring thing because we want to see if a problem is there or where the problem comes from, or also to have a prediction if there could come a problem in the future, or to prevent failures. So while we are in the situation to have an error, there will be some symptoms and the root cause, of course. But mostly it's the user who's taking his phone and tries to call someone if there's a problem in the service. Then he takes the phone and tries to call the service center and is telling maybe something like, well, the network is broken again. Normally, the service center guy will call the network department. They will check the network and see everything is fine. Then they will call the server administrators. The server administrators will call other departments from the application, for example, and so on. So what happened is everyone calls somebody and everyone is saying everything is working fine. But while we have those dependency trees, we can see if all the KPIs are working fine and everything is working like expected. And when we can see that the user can't work because there are no bookings, there is no income, there is no transfer of data or whatever the user does, we can take a look deeper into application information, middleware information, or backend information. All those things are coming out of KPIs from the dependency tree. And all those symptoms from the middleware, from the database, from the application, from the user, and so on, will be reported by notable events. And those notable events all belong to a root cause. And of course, the service center don't want to have each notable event and figure out, is this a root cause or is it just a symptom? So with ITSI, you can build episodes out of many notable events. But how to group those notable events? In the standard packages, there are some notable event aggregation policies which build episodes, for example, by hostname and so on. But mostly you just want to have those information for just one service tree, which belongs to one service. And there's an easy method to bundle those notable events which belong to one dependency tree. To tell ITSI which services belong to one service dependency tree, we have to tag each service. In this case, we have the tag ABC as a prefix. This must be done in each service. For example, if you have got a communication service, then you can just write COM for communication as a prefix in each service name. If you have done this, you have to go to a saved search, which generates the file ITSI KPI attributes.csv. This base search can be configured to tell the system this list is for grouping services to a alert type group. And in our case, the alert type or the alert group is the prefix. So we can easily create the group name, which is just the prefix for each service. And as you see, now we would have 4 services in our ABC group. So also a naming convention is key for building the right episodes and for a correct alert routing. When we have filled our ITSI KPI attributes.csv correctly, we go to our notable event aggregation policy and just say we just want to group our episodes by alert type, as mentioned in this case ABC. And so the grouping is correct. To make your life easier, Many people have already created some service dependency trees. These service dependency trees are mostly stored in content packs or in specific apps. Examples are the Microsoft O365 app or the Exchange app, which are coming out of the content pack. Specific app is for SAP, but keep in mind, when you take those dependency trees out of the content pack or out of the application, please take a look at the documentation, because sometimes you have to do some small configurations to make them work. Here you can see the service dependency tree, which is built by the SAP application for ITSI. Why each system is different? You of course have to configure the KPI thresholds. Therefore, you have to talk to somebody who works with the system, best a system owner, and then he can tell you which KPIs have to be in which range. If you've got more than one SAP system, during setup for each SAP system, an individual tree will be generated. But sometimes it is necessary to automatically update trees. This can be if your infrastructure isn't static and you don't want to check every day if there are changes. So for example, this could be an environment where branches are opened and closed sometimes in a year. That means you could check daily in a list or in your data, is a new branch opened? And if there's a new branch, you just want to create the ITSI service dependency tree out of those information. As an example, I've chosen the virtualization service. In this case, we get information from the VM, from the ESXi server, from each host, from the vCenter, from the storage, and from the management systems. And as mentioned, the dependency which device belongs where is in the data. Here you see we have got our vCenter. Under each vCenter we have some areas. In each area we have the VMs, the ESXi, and the data store. And if in a new area a new location is opened, number or the name of a new location is found, and the new location is added automatically to this tree. So if you don't work with these automatic tree generations, your ITSI will be outdated very fast. If this happens, the acceptance for the tool is really low. And if the acceptance is low, nobody would use it, because then the information is also incorrect. And of course, you don't want to have a process when you have to create or delete parts in the ITSI. It is too much workload and too many static processes where errors can occur. Also, valuable data for building service tree in the ITSI can be taken out of third-party tools like a service bus or a CMDB. A service bus, for example, is telling you which device talks to which other device. Or in a CMDB, you will find information about entities. In a normal CMDB, an entity is called CI, and it can be also implemented, and all the CIs can be imported every few hours. These are really necessary information to have a better quality in your service intelligence. As you see, mostly you get a comma-separated list with information, and with this information you can create new services. And if your naming concept is consistent, you're also able, by creating the new service tree, to add the corresponding service template and entities. In all the scenarios, we have been in business service or technical services. But let's take a short excursus to a different scenario. You could also use ITSI in production environments. Here is a demo environment for our IoT department. Our IoT department often has to build dashboards for production devices. And to have a showcase, they have built their own production lane. Let me just explain what happens in this case. As you see, we have two boxes. One of them is in Wiesbaden and the other one is at Dresden. In the middle of each box, there is a disk. The disk is simulating a transport belt. And on the disk, there are products. And the products have to travel from the first to the second to the third station where something is done on the product. As you see, On the top of the boxes, there are 3 devices. The first and the second device is for drilling and milling. The third device is for varnishing. So that means each product is going to the first or second machine. The work will be done, and then it's going further to the third machine, where also the work will be done, and then it's finished. So our idea was to build this productional service into ITSI because it's a service. As you see, we have those 2 production lines for each department. One is Wiesbaden, the other one is Dresden. But as mentioned before, the drilling milling station is just one service, but 2 machines in each department. This is the reason why we have just KPIs for the pieces which come out, for the workload and so on, for one service, drilling milling in Wiesbaden and Dresden, why we are not having 2 of them, because as mentioned, it's just a service. For varnishing, we have just 1 machine, so there is in each service 1 machine. The transport service itself is needed for the drilling milling and the varnishing. So the dependency is built up. If the transport system will fail, the work pieces can't be brought from one station to another, and so all the service fails. But as mentioned, just for one department, while the transport systems are different. This is a great solution to have information from different production services, maybe old ones, maybe new ones. And so you can have this line of production in ITSI and take information from several old machines and build up your production line as you have it in your company. Let's review some stuff. Keep load in mind. Use more time and write some small, easy and valuable KPIs. KPIs are running cyclic, so use base searches and entities to reduce load, create templates if your set of KPIs is used in many services. Stay in the service view. Always think in services. What's useful for the end user, who's normally a business guy or someone who needs information out of a technical service. Use infos from already existing sources. Don't try to develop everything by yourself. Keep it dynamically or have automatisms. I hope there have been some useful information from you. As mentioned, many things of this are just basic stuff, but in the field you can see that also these basic stuff isn't always handled correctly. Thank you for watching, thank you for attending, and hope to see you soon. Have fun at B-Sides.